Why, hello there. Specific gravity of water, yes. So I'm drinking a hot chocolate, which has a higher specific gravity than water does. But do you even know what specific gravity is? I don't know. But you will know after this presentation. So, the first thing we need to know about specific gravity of water is density. Now, density is signified by the symbol rho, and it's kind of a slanted P, which is equal to mass over a volume. And as you know, a volume is just length times the width times the height. So if we have a mass in kilograms and each of these values is 1 meter, then the volume will be meters cubed. Now, how does this relate to specific gravity? Specific gravity is the P of an object over the P rho of another object. And in this case, we're doing water, so it's going to be the density of water. Now, we'll take gold, for example. That seems to be a popular substance, metal. Gold has a density of 19,300 kilograms per meters cubed. And this has a fairly high density compared to other materials. That's why it's so precious. So if we were finding the specific gravity of gold, it would be 19,300 over 1,000 kilograms per meters cubed. This one also is kilograms per meters cubed. And this right here is the specific gravity of water. So, the specific gravity of gold would be 19.3. And it's important to note that this has no units. It is merely a ratio. So, you're married, or maybe you're not married. Maybe you will be married. And in that case, you need to know how real your ring is, the integrity of the ring that you are wearing. So you measure gold in carats. And the higher the density, the more carats your ring is going to possess. So how do you figure out how many carats your ring is? Oh, I ask that on a daily basis. Oh wait, I don't. All right. So you have a ring, and you measure it on a scale. And it comes out to be 3.5 kilograms. If you want to know the specific gravity of that ring, you'll submerge it in water. Make sure it's not touching the ground or the sides. And make sure that you zeroed out the weight of the water, so you're only measuring the weight of the submerged ring. And it comes out to be 0.3 kilograms. Say, this is kind of held up by strings or something. So to find that specific gravity, you take 3.5 divided by 0.3. And so bring that in. You have 1 point, this is quick math, 6. So you have a specific gravity of 11.6. So then you would go to a chart. You can find it anywhere on the internet and find what density or what carat 11.6 is. And I think, thinking back, that is about 10 carats, 10 carat ring. And I think 24 carat is the highest amount of carats, and that is the specific gravity of gold, which is 19.3. So if that's you, yay you have a nice ring. So yeah. So lastly, the last principle I want to talk about is ice. And so ice has a density of 920 kilograms per meters cubed. Now we remember that water has a density of 1,000 kilograms per meters cubed. So that would mean that ice has a specific gravity of 0.92, just no units, just a ratio. And so this would mean that if ice was submerged in water, 92% of the ice would be in the water, leaving 0.8 out of the water. And so if you look at an iceberg, this is really cool because only the top 8% is out of the water, and really you have a ton of ice under there. So some people are like, icebergs, you don't really know. Don't really know. A lot is under the surface. So this would hold up for any object. Wood, obviously gold has a specific gravity of 19.3, which is above 1. So anything above a specific gravity of 1 is going to sink. And so yeah, that is just 2 basic ways we can relate specific gravity to everyday, specific gravity of water to everyday life. And I think they're pretty cool things. So I'll let you get back to whatever you're doing, and I will start sipping my hot cocoa again.